Hello everyone, and welcome to my Deep Learning Project presentation. Today, we'll dive into the fascinating world of deep learning to analyze and forecast global temperature trends. Our journey begins with Step 1: Data Loading and Statistics. We load the temperature data and calculate key statistics such as mean maximum and standard deviation. Moving on to Step 2: Data Normalization and Pre-processing. We ensure our data is ready for training by normalizing it using min-max scaling. Now, let's delve into Step 3, constructing LSTM and GRU models. These models will help us uncover patterns and insights from the temperature time series data. In Step 4, we train and evaluate our models. The LSTM and GRU models learn from the historical data, and we monitor their performance during training. Now, let's visualize the training and validation loss curves. These curves provide insights into how well our models are learning from the data. Additionally, we assess the models using confusion matrices and accuracy metrics. This gives us a comprehensive understanding of their performance. Moving on to Step 5: Forecasting with GRU. We leverage the power of the GRU model to predict future temperature trends. Let's visualize the forecasted results. Comparing our predictions with actual values helps us gauge the accuracy of our model. In conclusion, we've uncovered key findings from our analysis. The GRU model has proven to be a powerful tool for temperature prediction, demonstrating the significance of deep learning in climate analysis. Another task is Intel image classification. We'll kick things off by fetching our dataset from Kaggle and ensuring our data is properly normalized for effective model training. Task 2 takes us deeper into the heart of our project. We'll explore the intricacies of image classification, harnessing the power of a convolutional neural network, a key player in deep learning. With our data prepped, it's time to train our model. We'll unravel the training process, explore critical hyperparameter choices, and understand the importance of dividing our data into training and validation sets. As we evaluate our model's performance, we'll visualize its learning journey through plotted training and validation losses. We'll also delve into the confusion matrix and explore the accuracy metrics that guide our assessment. Finally, we'll bring our exploration to a close by showcasing a graph that unveils the predicted classes for a selection of images. Get ready to uncover some intriguing insights from our model's predictions. In conclusion, we'll summarize our key findings, reflect on the challenges we faced, and discuss potential avenues for future improvements and exploration.